I'd like to thank Energy Press and Mr. Panagoulis and personally for the invitation to this conference on renewables and storage, and I believe that I can contribute significantly to some of the concerns that have been expressed, and our group has developed some solutions that can offer solutions, and especially through interconnections. In our journey towards net zero emissions, the International Agencies Association has made some assessments on what's going to happen to the networks during the years to come. And we see that until 2020, there was around 200 million kilometers of lines. That's going to go beyond 4 million by 2030. In 2040, there's going to be a further 50% increase, and the biggest part of this is going to concern the connection or the interconnection of renewables. And at the same time, there's going to be a need for substations for the penetration of this renewable energy into the network. Another element that you can see here is that there's going to be digitization. So the systems are going to use technologies, digital technologies, and power electronics. So therefore, something that we were designing 15 years ago, we can see now that we now see that over the next 15 years, the network is going to look like we see here, with a lower need, by reducing the CO2 footprint, with a higher ability to utilize the produced energy, a greater degree of control of the network, and also more power electronics that can enable this situation. So the question that we have here today, and we're discussing here, is whether it's storage or transmission. Then the answer is very simple. Because when we have two different networks, the exchange of energy is when you have a surplus, or when there is a decision to transfer some of that energy for a later stage. But the optimal mix is based on the difference in price of the margin price. So the greater the margin price, we see that it's not worth storing locally, but to move towards the neighboring system that's closer to consumption. But even in extreme situations where there's a big difference, one part is going to be storage, of course, because it's consumed locally, whereas the other one is transferred. Therefore, talking about offshore installations, we see that the ones that have already been installed, they started close to the coastline, 10, 20 kilometers, but now we're just talking about installations that are further, because there we can have significant economy of scale, and we can reduce the cost. Additionally, we see that the HV transition is so we're using that's why we have an installed base of around 300 gigawatts. We have an increase which is 3 times the growth rate of the global GDP, and what you see here is the installed capacity by the company, which is 50% higher than the global installed base. And if you see in the Northern Sea, where we also have shallow waters, the production is, the interconnection is continuous. But up to now, we've seen point-to-point interconnection, so that something is produced and is transferred. With the technical know-how and the experience, the Hitachi Group through the experience and the will of the interested parties to use common infrastructures. So in other words, you can have a cross-border interconnection of networks with continuous electricity supply, which means that you can use the infrastructure when there's wind in one place and not in another, but also be interconnected to other countries with a different energy mix, therefore exchange energy that's produced through different systems. So the new innovation is that in networks which are interconnected point to point, we can install terminal stations and using the main network without having to use additional networks. And this is because the technical know-how that we have, we can now check the flow towards every terminal and send the energy to an area that has a higher demand and a higher price at that given point. This is not something that happened by itself. It's something that even 10, 15 years ago that we've already had one of those systems that's been operating in India, and it transmits 6,000 megawatts from one end of the country to another, supplying around 90 million people. The biggest interconnection between Norway and Germany started initially because it wanted to utilize the cheap hydroelectric energy from Norway, but while there was a surplus of renewables in Germany, then of course this was being sent back, and it could be used either in Norway or it could be transmitted to a neighboring country such as Finland or Sweden. A similar application in Norway, between Norway and the UK, which can be used it's multi-terminal enabled, which means that it can be further extended by adding more terminals. This is already happening in some cross-border interchange between Saudi Arabia and Egypt, where Saudi Arabia is already using the terminal, and we have stations which are 3,000 megawatts each with an inter-terminal between them. Now, we also have an installation which is the first in Europe, which while it started and it was activated in 2018-19, it had already been designed and it was going to be used for the electrical supply of the Shetland Islands with the use of a switching station, and you can see there's a capacity of 1,200 megawatts, 800 and 600 for the intermediate one. And
Northern Scotland, a land of tremendous renewable energy resources ready for harvesting. Using Hitachi Energy's high-voltage direct current light technology, Scottish and Southern Electricity Networks transmission has connected the electricity grids on each side of the Moray Firth and will now connect Shetland. The 1,200 megawatt Caithness-Moray project is key to improving grid resilience. And with the Shetland link, it completes Europe's first multi-terminal HVDC light system. The multi-terminal solution allows power to flow in multiple directions with minimal power losses, providing maximum flexibility, power reliability, and supply security for both Scotland and the UK. The link is designed as a 5-terminal system to be ready for future HVDC extensions and will support power exchange and cost optimization while lowering the carbon footprint. Supporting the UK's decarbonization target to bring all greenhouse gas emissions to net zero by 2050.
Αυτός είναι ο τρόπος που
That's the way that our group is helping in reducing the cost of infrastructure and increasing their efficiency, and also creating a more commercial product, so that because making more infrastructure that is not affordable for others to buy, there's no point. So therefore we need to create a more competitive product. Thank you very much.